Hi, I'm Chris with Sanderson Test Prep, and in this video we want to take a look at a teaching tip. So this video is more for teachers and tutors out there, and we want to look at these two things in this video. So the first is, it says avoid bulldozing. So let's talk about what bulldozing is. Bulldozing is when you bulldoze through a question and explanation without giving a student an opportunity to respond and demonstrate their knowledge, or you simply ask the student yes/no questions. And that really takes away a student's opportunity to actually think, process, and internalize the concepts that you're covering. So we're going to go through this sample question here. I'm going to show you an example of bulldozing in terms of solving this question. And then we're going to go through it another time and talk about the right way to do it by bouncing around the room. So first, let's avoid bulldozing. And I just want to show you an example of what that might sound like. So when you're covering a question in class, we'll take a look at this example. It says if x plus 1 over 3 equals k and k equals 3, what is the value of x? So if I were a teacher bulldozing this question, I'd say, okay, so on something like this, what we need to do is we need to get rid of that denominator, right? And so to do so, we want to multiply both sides by 3 to cancel that out. So we go times 3 to cancel it, and times 3 over here. So then we get x plus 1 equals 3k. And then what do we do next on that? So next, if we wanted to get x by itself, we could subtract 1, right? So if we subtract 1, then we'd get x equals 3k minus 1. And we know the value of k is 3. So if we plug that in, x would equal 3 times 3. And what's 3 times 3, guys? 9, right? Okay, good. So then 3 times 3 is 9 minus 1, and we get x equals 8 as our final answer. Does anyone have any questions on that? Okay, so that's an example of bulldozing that question, because if we take that approach, we don't really give students an opportunity to participate in solving the question. And from an assessment perspective as a teacher, it makes it a lot harder to know where your students really do have the questions, what concepts they're understanding, what concepts they need a little bit of practice on. Okay, now many of you might have looked at this and said, oh, well, you could substitute in for k first. And I'm going to do that same example over here. But again, I just want to demonstrate what bulldozing a question looks like. So if we were to have substituted in for k, that would look like this. It's still x plus 1 over 3 equals k to start with. And then if we substitute first, that's perfectly okay. We could do x plus 1 over 3 equals 3. Again, to cancel out our denominator, we're multiplying by 3, right? You got to multiply by whatever the denominator is to cancel it out, okay? Remember that, guys. And then we get times 3 over here. X plus 1 is 9, and then we subtract 1 from both sides, and we get x equals 8 as our final. Okay, so does that make sense? Do you guys have questions on that? So again, that's a good example of how we could bulldoze a question and take away an opportunity for students to learn. So now we're going to take a look at the other way of approaching this that's a little bit more effective for creating student engagement, and from an assessment perspective, really being able to see where students have questions. And we call it bouncing around the room, and we're going to cover that now. Okay, so we just finished talking about how we could bulldoze a question and why it's important to avoid that. So now let's see the right way to do it with this same example. So bouncing around the room, to bounce around the room, by the way, if anyone happens to be a Fish fan, great song if you want to check that out. But to bounce around the room from a teaching perspective, what that means is to call on students by name, but you want to bounce around the room at random. You don't want to go in order, because what happens if we go in order? So if you start at seat 1, seat 2, seat 3, and you're calling on students, even if you're calling on students by name to help participate or help walk you through a question, students begin to predict when they're going to be called on, and they know that they have to start paying attention once it gets to their row, once they're a few seats away. So they kind of tune in for a minute, give their answer or their response, and then they know that they're not going to be called on for another several minutes as we snake around the room in an order. So then the student will tune out for 10 or 15 minutes until it gets back to them. So we want to bounce around the room so that students feel like they could be called on at any given time to maximize the engagement that we get from students, so that everybody feels the need to pay attention and know what's going on. And when you call on students, you want to call on students by name. And as a teacher, you probably know your individual students and their strengths and weaknesses. So typically speaking, if you know a student is going to struggle with a certain aspect of a problem, but maybe be more comfortable with another aspect, you want to try to call on students where they're going to be able to answer it successfully, so that, again, it furthers that engagement and keeps students interested, feeling confident about the material, and also helps the class progress along smoothly so that students will not lose interest. So let's take a look at an example with that. I'm just going to call out students with random names and give student responses so that we can see how we could incorporate several students in solving just this one problem. So it might just be one problem, but that doesn't mean we only have to call on one student. So here's what solving this question with bouncing around the room might look like. So, okay, here's our sample problem. We have x plus 1 over 3 equals k. So when we take a look at this problem, Kayla, can you tell us what you would do as your first step? So Kayla might say that she would multiply both sides by 3, and that's absolutely right. So we would multiply both sides by 3. And then Danny, can you help me simplify this? What would this look like after I've canceled that out? So hopefully Danny says x plus 1 equals 3k. And then we say, great job. Now Steve, can you tell us what you would do as your next step here? I would subtract 1. Great, awesome. So we're subtracting 1 from both sides. And after we do that, we have x by itself. And Lindsay, can you tell us what that's going to look like when we have x by itself? So that'll be, and Lindsay hopefully says 3k minus 1. And we say, great job. And now for our last step, Veronica, can you tell us what we would do here? I would substitute in the 3. Good job. So if we do that, we substitute in the 3 in place of k. And then to finish it off, Mike, can you tell us what our final answer is going to be? Well, 9 minus 1 would be 8. Great job. So if we take a look at bouncing around the room with that, we had 1, 2, 3, 4, and a final 5 students engaged in just that quick minute or two of solving one individual problem. So we maintain the engagement of the entire room by bouncing around the room and calling on students by name. It's one of the most effective teaching practices, especially if you have a larger classroom. If you're teaching to 10 or 15 students, sometimes you can call on one student, every 5 or 10 minutes and still keep a little bit of engagement. But if you have a classroom like many of us do, where you're looking at a class of 30, 35, sometimes 40 kids, then you really do need to use bouncing around the room effectively so that you can maintain that student engagement and keep students responding quickly so that the pace of the class is exciting enough for students to not lose interest. For more, please feel free to like and subscribe, and thanks for watching.